Let's start section 9.2, which is about possibility trees and the multiplication rule. So we're going to start with what a possibility tree is. So let's start with that definition. A possibility tree shows all possibilities in situations in which events happen in order. So we're going to look at an example. Let's say I have two teams. I'll call the first team A and the second team Team B. And they are to play each other repeatedly until one wins 2 games in a row or a total of 3 games. So these two teams are playing in a tournament, and the tournament ends when either one team wins twice in a row or wins a total of 3 games. And I want to know how many ways can the tournament be played. So here would be a good case of using a possibility tree because there's a game 1 and a game 2, and so events are happening in a certain order. So let's draw the possibility tree here. So here is where I'm going to draw a point here, and this is the start of the tournament. And so the first thing that's going to happen is they're going to play game 1. And what are the possibilities for the winner of game 1? Well, Team A could win game 1, or Team B could win game 1. Now here, the tournament must continue in either case because no one has won 2 games in a row or 3 games in total. So, gonna have to go to a game 2. And what are the possibilities? So for each one of these, if A won the first one, either A could win the second one or B could win the second one. And the same thing here, if B won the first game, A could win the second one, or B could win the second one. Now, I want you to take a minute and look at this top path right here. A has won twice in a row, and so if that happens, the tournament would be over. But now if I look instead at this the second possibility here, A won the first game and B won the second game, so the tournament is not over. In that case, we would have to continue to a game 3, and there are 2 possibilities. Either A wins or B wins. And then the same thing on this path right here, each team has won once. So there would have to be a game 3. And either A wins or B wins. And in this last case, down here, B has won twice in a row, so the tournament would be over. All right. So let's look now at our possibilities coming off of game 3. If I look here at this path, A won the first game, B won the second game, and A won the third game. Nobody's won twice in a row or 3 times in total. So here, I would have to have a game 4. So we'll say winner, game 4. Here, either A wins or B wins. But if I look at this one down here, B has won twice in a row, so the tournament would be over. Same thing if I look here, A has won twice in a row, the tournament would be over. But if I look here, nobody's won twice in a row and nobody's won 3 times total. So here I would have to have a game 4, and again, either A wins or B wins. So let's look at these game 4 here. So along here, A won game 3 and game 4, so the tournament would be over. A would win. If I look here, nobody's won twice in a row, and if I look, nobody's won 3 games. So this one would have to go off to a game 5. And again, either A or B could win. Along here, each team has won twice. Nobody's won twice in a row. So this one would have to branch off into a game 5, A and B. But if I look at this last one, B has won twice in a row, so the tournament would end. So now let's look. If I look at our game 5, is the tournament done? Here, if I trace back the winners, A won 3 times in a row, so the tournament would be over. If I look here, B won twice in a row, so the tournament would be over. If I look here, A won twice in a row, the tournament would be over. And then if I look at this very last game 5 here, B won 3 times, so the tournament would be over. So now we've written out all the possibilities in this possibility tree. This is what the picture looks like. And so the beginning, we often call this beginning part the root. And then these terminal points here, these points at the end that don't go anywhere, these are called roots. And so what I want to know is how many paths do I have from the root to the tree, from the root to the leaves? Oops, sorry. These are called leaves here. These are called leaves. And how many paths do I have from the root to each leaf? How many of those do I have? So there's 1, 2, follow along. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10. So there are 10 paths from the root, which is where we started, to the leaves, which were the last possible game to be played. So basically, there are 10 ways for the tournament to be played. So my answer is 10. And so now part B of this question says, assuming that all the ways of playing the tournament are equally likely, what is the probability that 5 games are needed to determine the winner? So how many leaves did I have that ended in a 5th game? So let's look back at our possibility tree. If I look here, I had 1, 2, 3, 4 of them required a game 5. So we're going to use our probability formula from the last section. There were 4 that required 5 games, and then there were 10 ways in total, so 40%.